All right, guys, here we go. I'm gonna be canceling tutoring today, so no tutoring today. We were gonna do the free response questions of Mock 2, but we'll just push that. Um, I know tomorrow. I think I told the decathlon team we might or octathlon team that we're gonna meet. So we'll just push it to another day. Not a big deal. Let's talk about limits. Uh, no one got this question correct on mock exam 2, like no one. And that's okay. That's because we haven't talked about limits. So now that we talk about limits, you will know how to do this. So relax. Does someone want to, hey, Ms. Bayet, do you want to read this for us? All this stuff? Yeah, it's not that much.
All right, let's start with limits. What is a limit? What does it mean to find a limit? Let's start with notation and go from there. A notation for a limit will look like,
You can just say that. That.
okay, will look like that. Relax, it's not that bad. This is read the limit of f as x approaches c is equal to f. If you want to call the function f of x, then you could also say the limit of f of x as x approaches c equals l. Basically, informally, the limit is a y value which a function approaches as x approaches some value. That means as x approaches c, f of x approaches the y value of l. You will also see that and that.
Okay, so the difference between the first that and the second that, you see that little minus? That little minus means that you're approaching from the left, and you see that little plus? That plus is kind of like an exponent. That means you're approaching from the right. Okay, keep going by it.
Okay. This means x is approaching from the left
Oh.
to right, respectively. Let's practice finding limits graphically and using correct notation.
Yeah, keep going.
The graph to the right is, let's see.
2x squared plus 5x minus 3 over x squared minus 9.
Okay, right. The coordinates of the hole in this graph are -3, 7 over 6. The red dashed line is the vertical asymptote x equals 3. The blue dashed line is the horizontal asymptote y equals 2. Let's chat #math live. Let's see how we could have obtained
Okay.
this sketch of all these asymptotes.
So, yeah, thank you, Ms. Baye. So all this is stuff that you should already know from Algebra 2. If you have colored pencils, because I know that we couldn't print out that copy there, the red dashed line is your vertical asymptote, and the blue dashed line is your, or if you have a pen, use a pen, red and blue pen, or whatever the situation may be. It doesn't have to be a pencil. You can use a highlighter or whatnot, just so you can have good notes. All right. From your Algebra 2 days, let me go ahead and write f of x equals 2x squared plus 5x minus 3 over x squared minus 9. From your Algebra 2 days, do you know how to factor out the numerator? The denominator, I think, is easy to factor out. It's the difference of squares in the bottom. So there's going to be x plus 3, x minus 3 in the denominator. But in the numerator, there's only one way to get 2x squared. That's 2x times x. Well, at the high school level, right? There's only one way to get a -3, and that's 1 times 3. Let me do it wrong on purpose. Okay, so don't write this one down. This is the wrong one. 3 and 1. Chop, how do you know this is a wrong one? Because look, if I do 3 times x and then 2 times this one right there, that's 3x and that's 2x. I need the difference to sum up to 5, and the difference between 3x and 2x is not 5. Do you guys see that? So I need to have the 3 over here and the 1 right there. And now it's going to work. 1 times x is x. 2x times 3 is 6x. The difference between 6x and 1x is 5x. Do you guys see that? Now I need the larger number to be positive because, look, it sums up to 5x. So 2x times 3, this guy has to be the plus, and this guy has to be the minus. Now, from your Algebra 2 days, hopefully you guys remember, if you have a factor in the denominator that's the same as a factor in the numerator, those cancel out. And when you cancel those factors out, this is called a whole. So you have a whole at x equals -3. Or you can also say a removable discontinuity. Removable discontinuity. Does any of that look familiar to you? None of that's familiar to you? Oh, okay. We'll see what type of shape we are in with rational functions. Hopefully we're in okay shape, but if not, we'll do a lesson. We'll try to do a lesson. All right, there it is. That's how I got the hole there, guys. So Chop, how did they get the hole there? Well, plug in negative 3 into whatever you have left. So look, 2 times negative 3 minus 1 over negative 3 minus 3. And you get negative 6 minus 1, that's a negative. Negative 3 minus 3, that's a negative. Negative divided by a negative is a... So there it is, a whole. My x value is negative 3. My y value is 7, 6. That's how they got that whole right there. Negative 3, comma, 7, 6. Now remember, guys, you can't divide by 0. So this guy right here, x minus 3, x equals 3 is a vertical asymptote. That's the abbreviation or acronym for vertical asymptote, VA. So notice at x equals 3, they're the red dashed line. Do you guys see that? Okay. All right. Horizontal asymptote. This is how I've been teaching it, and my kids always seem to understand it. Let's talk about conceptually. If you spit in the ocean, does the ocean rise? No. So when you talk about horizontal asymptote, you're talking about very, very large x values, magnitude-wise, either in the positive direction or the negative direction. Chop, what are you talking about? End behavior. Look at the numerator. 2x squared plus 5x minus 3. In the numerator, the ocean is the 2x squared, and the 5x minus 3 is spit. As x is really, really large, we don't care about the 5x minus 3. We just care about the 2x squared, because the 2x squared is like ocean. So look, 2x squared. In the denominator, I have x squared minus 9. The x squared is ocean. The 9 is spit. I'm talking about as x is really, really large. And look what happens. 2x squared over x squared, what cancels out? And look, you just have 2. So this is when you're talking about large values. So look at this graph. If I approach negative infinity, I'm approaching the horizontal asymptote of 2. If I approach positive infinity, I'm approaching the horizontal asymptote of the y value of 2. Do you guys see that? Does that make sense? Okay, so that's all it's about. Hopefully you did something like that in your Algebra 2 days. If not, we'll try to do a lesson. It's probably going to have to be after school, guys, because we're getting really close to the end game. So is that okay with you guys? All right. So there it is. Let's go to the next page. And don't worry, we'll finish pretty quick. So this right here, it's the same graph. Man, I'm having a real hard time. Same graph. I don't think I'm sick. I think this is just allergies. No.
Yeah, you're standing up over there. It's like a good 6 feet.
Sorry. Was that a joke? Were you? Oh, okay. I thought you were trying to beat me up. What's up, Pearsall? What gives me a 0 in the denominator? You know what I mean? Look, right here. You know what I mean? Good question. Keep asking. All right. So this means as x approaches negative infinity. As x approaches negative infinity, this is a y value. What is y approaching? We said it right now. 2. Put a 2 there. How does this look in limit notation? Like this. You write the word LIM. That's for limit. And then in the bottom of the word limit, you write x approaches negative infinity. My infinity doesn't look all that good. Let me do it better. Then you write of this function f of x. If you have what the function is, you can write the function also. You could have also written this expression in there. But the name of it is f of x. The limit as x approaches negative infinity of this function equals 2. And that's it. That's what I'm approaching. Limit as x approaches infinity. Well, if I approach infinity, what is the y value approaching? The same thing, 2. As x approaches infinity, as x approaches infinity, the y value approaches 2. So again, limit as x approaches infinity of this function equals 2. All you care about is what you're approaching. You don't care about if you're defined there. Look at this next one. It says negative 3. Here's negative 3, guys. I don't care that it's discontinuous. We don't care that it's discontinuous. We just care what we're approaching. As I approach negative 3 from the left, underline the word left. So here it is. I'm going to go slow. So here's my little laser. If I'm approaching from the left, that means I'm approaching from numbers to the left of -3. So as I approach -3 from the left, look at this arrow. What's that y value that I'm approaching? 7, 6. 7 over 6. If you want to use that line as a fraction, 7 over 6. So here we go. I'm going to write the word limit. As x approaches -3 from the left, so on the upper right-hand corner, you put a little minus sign like that, of this function, equals 7, 6. We still okay, guys? All right. As x approaches -3 from the right, the graph of f of x approaches, okay. Well, if I approach -3 from the right, so I'm looking at numbers to the right of -3, as I get really close to -3 from the right, what's that y value that I'm approaching? 7, 6 again. So I'm going to write limit as x approaches -3 from the right, put a little plus symbol on the upper right-hand corner of this function, and it's going to equal 7, 6. We still okay? All right, next one. As x approaches -3, it doesn't say from the left or the right. So do they converge from the left and the right? Am I converging on the same y value? Yes. So this is going to equal the same thing. Take a guess. What if they did not converge on the same y value? Then we would do the Lindsay Lohan. Do you guys know who Lindsay Lohan is? Maybe you guys are too young to know. Do you guys remember the movie called Mean Girls? What did Lindsay Lohan say in Mean Girls when she was doing that math contest? Yeah, the limit does not exist. If the y values would have been different, you would have said the limit does not exist. We're going to write limit as x approaches -3. You don't have to write a left or a right because it's, of this function f of x. And because the left and the right both match, you can just write 7, 6. Match. So, does that make sense? All right, turn the page. Sorry, I should have put the graph there. Next time I'll put insert graph. Insert graph. You'll see this again next year in calculus. As x approaches 3 from the left, the graph of f of x, okay. If I approach 3 from the left, here's 3. If I approach 3 from the left, what's happening to my y values? They go down forever. So I'm going to say negative what? Negative infinity. So, negative infinity. So how do you write it? Limit as x approaches 3 from the left of this function equals negative infinity. You could also say it does not exist because infinity is not a number, but this is fine for now. Limit as x approaches 3 from the right. Okay, well, here's 3. If I approach 3 from the right, look what's happening to my y values. Infinity. Limit as x approaches 3 from the right of this function equals infinity. Are we still okay? All right. Limit as x approaches 3, the graph of f of x. Well, look, if I approach from the left, it's negative infinity. If I approach from the right, it's positive infinity. Do they match? So we're going to say does not exist. Limit as x approaches 3 of f of x does not exist. There's some textbooks that say don't put the equal sign in there. I mean, yeah, I guess they're right, but it doesn't matter. If you put equals does not exist, I wouldn't count it against you. Your professor might. He might be one of those that like, oh, it needs to be perfect. Whatever, professor. Whatever, Dr. Chance. Nah, I love you, Dr. Chance. I'm kidding. He was really brutal. He wasn't a bad guy. He was just he wanted things done a certain way. After I got done with his class, I went back to my way. All right, there it is, guys. This we already talked about. All that means is that your limit exists. If you approach from the left and you approach from the right and it equals the same thing, then the limit exists. That's all it means. If you approach from the left and you approach from the right and you don't equal the same number, then you're going to say the limit does not. That's it. That's all this means. All right, let's see if we figured this out. I'm gonna go down the line here. Oh, I'm gonna start on this table. Don't worry, this is a low stress situation. All right, buy it. So letter A, it says limit as x approaches -1 from the right hand side. So I'm looking at this graph. If I approach -1 from the right hand side, what's that limit? 1. There's only one direction to go. One direction. You can only approach from the right hand side. You can't approach from the left. So they're not going to have limit as x approaches -1. That makes sense. All right. Rodriguez de Lara, ready? Limit as x approaches 1 from the left. So here's 1, and I'm approaching from the left. What is that y value? What is it? 2. Yeah, good job. There it is. Ready, Miss Peters? Limit, I'm doing letter C. Limit as x approaches 1 from the right. So I'm looking at this one. If I approach from the right, what's that y value? 1. Good job. Ready, Miss Pearsall? Letter D. This just says limit as x approaches 1. Well, look, from the left it's 2, from the right it's 1. Do they match? So what am I gonna type or write? Does not exist. Good job. Does not exist. Chop, there's an equal sign. It's fine. Does not exist. If you want to delete the equal sign, delete it. Limit as x approaches 1 of f of x does not exist. There it is. Does everyone understand? Okay. Ready, Helena? Don't worry, you're fine. We don't care about discontinuities. Remember, we just care about where we're approaching. Limit as x approaches 2. So it doesn't have an arrow, so let's see. It's just in blue. If I approach 2 from the left, it looks like I'm approaching that y value. If I approach 2 from the right, it looks like I'm approaching that y value. What is that y value that I'm approaching? 1. There it is. That's my limit. See? Ready, Dogadillo? Limit as x approaches 3 from the left. Well, I'm looking at this. There's only one way that I can go to, this from the left. If I approach 3 from the left, what's that y value? 1. There it is. All right. Letter G. Does that one say the word limit? No, that says f of 2. This is f. When x is 2, what is my y value? Don't tell me 1. When x is 2, what's my y value? What is my y value? 2. Oh, but is that what they wanted? Oh, sorry. I put 1 there. I'm out of it. When x is 2, the y value is 2. You said the right answer, but I just said 1 for whatever reason. I don't know why I said 1. Did I confuse anyone there? When x is 2, y is 2. That's where I'm defined. It's this point up here. 2, 2. Sorry, guys. I said 1 there for whatever reason. We're good, though, right? Guys, we got it down for sure? All right. Let's go to the next page. Right, and on this, we're going to continue with you. So this one, I have a graph. This is a graph of f. Limit as x approaches 3 from the left. So on this, as I approach 3 from the left, what does that y value look like? As I approach, well, that's the x value. As I approach 3 from the left, what's that y value? 1. All right, ready, Pettis? If I approach 3 from the right, what does that y value look like? 3. Ready, Myers? 3 from the left is 1. 3 from the right is 3. So what is the limit as this approaches 3? Does not exist. All right. This one says f of 3. I'm going to look down x equals 3 to see if I have any point anywhere. Is there a point at x equals 3 anywhere? There's no point, right? There's no point. So this you're going to say undefined. Undefined is for functions. Does not exist is for limits. Are we okay? Yeah, that's it. We're good. All right, let's see what the next one says. Use the graph of the function f of x shown below in order to determine all values of a for which the limit as x approaches a of this function is 0. All right, you are 0 on the x-axis. So how many limits do I have? I need whole numbers. So it looks like there's at least one right there, another one right there, and one more. Good job with 3. Limit as x approaches -5 of this function is 0. See, if I approach -5 from the left and the right, it's 0. The y value is 0. Limit, dot. That's for a bullet, dot. Limit as x approaches 2 of this function is also 0. See, if I approach from the left, it's 0. If I approach from the right, it's 0. And limit as x approaches, is that number 8 over there? Of this function is 0. They wanted the a values. These are the a values. So you're going to say a equals -5, a equals 2, a equals 8. Is all this making sense, guys? All right, let's go to the next one. This is called a piecewise function. I hope that we have experience with that in algebra. Do you guys remember piecewise functions in algebra or maybe in the UT high school stuff, right? Okay. Piecewise functions. All they mean is that there's a domain restriction. So I'm gonna go slow, guys. Here's my sketch. Let's see, 0, 1, they're all quadrant 1. So here's my sketch. I'm gonna start, let's color code it. I'm gonna do this one in blue. I'm just gonna go down the color. So here we go. That has a y-intercept of 1. So I'm gonna put a 1 right here. I'm gonna say that's 1. And my slope is -1, and I go all the way to from 0 to 1. So here's 1, and that's gonna be an open circle right here on this one. So that's open. Is everyone okay? I'm gonna put this one in burnt orange. Go Longhorns. It tells me that between 1 and 2, my value, the y put, is always 1. So here's 1. And I'm going to say here's 2. The x value of 2. And my y value is always 1. So there it is. And that's open. Bless you. This is just a point. I'm going to put this one in black. That point is 2, 2. So I'm going to say here's 2. I'm going to put a point right there, 2, 2. I'm going to put this one in red. I don't know how that looks. Or it's a linear line. Just plug in the 2. 2 minus 1 is 1. So I'm gonna start at 2, 1, open circle. And at 3, 3 minus 1 is 2. So here's 3. Here is 2. And close circle. And connect them. Are we still okay? Yeah. I'm going to go to purple. I'm going to say this is purple. At 3, plug in a 3 in there for the x. -3 plus 5 is 2, so that means I start here. You could put it open if you want, but it's closed from the red one. And if I plug in a 4 in there, -4 plus 5 is 1, so I'm back like right here. And 1. And connect them. And there it is. I'm going to go to a default color. I'm going to go to black. Now, where do we leave off? We left off in Myers, right? So we'll start over here. Are you ready, Chavez Lua? This is a low stress. Relax. You're fine. Letter B, I'm going to read it left to right. Limit as x approaches 0 from the left. Well, there's only one direction. I can only approach 0 not from the left, from the right. I can only approach 0 from the right. So limit as x approaches 0 from the right. What's that y value? All right. Well, I answered that one, so we'll go to the next one. So, but I just want to make sure that we got this. Limit as x approaches 0 from the right. Approach 0 from the right. The y value is 1. So you're gonna answer this one. So the next one, I'm reading left to right. Ready, Chavez Lua? Limit as x approaches 1 from the left of this function. Well, if I approach 1 from the left, so here's my laser. Where's my laser? So here it is. If I approach 1 from the left, what is that y value? 0. What'd you think? Not bad, right? All right, Tony and Ishmael, ready? Don't worry, low stress, miss, low stress. Let me get my laser. Limit as x approaches 1 from the right. So here it is. Here's the x value of 1. As I approach 1 from the right, what does that y value look like to you? 1. Good job. Ready, Goda? So notice this one just says 1. So limit from the as x approaches 1 from the left is 0. Limit as x approaches 1 from the right is 1. So if I don't have a plus or a minus, that means that I got to make sure that these two agree. Do they agree? So what am I going to say for this one? Does not exist. Cool. Ready, Zamora Johnson? Or little Zamora Johnson, because I got the big one. Okay, anyways. So if I approach 2 from the left, see, here's my little laser. So if I approach 2 from the left, what does that y value look like to you? 1. Ready, Granados? If I approach 2 from the right, what does that y value look like to you? Yeah, good job. 1. Now this one here, it just says limit as it approaches 2. Well, from the left it's 1, from the right it's 1. So what is this limit? 1. I used to have a kid, his name was Juan, and every time we said 1, I would say Juan. I miss him. I hope he's doing okay. Hey Juan, if you're watching my video, all right, he's probably living his best life. All right, limit as x approaches 3 from the left. Okay, well here it is, 3 from the left. What's that y value? 2. Limit as x approaches 3 from the right. What's that y value? 2. What's the limit as x approaches 3? 2. Limit as x approaches 4 from the left. 1. Does this one say the word limit? What's f of 2? 2. That just means the function evaluated at 2. Do you guys feel good? All right, don't worry about this PoEV. I haven't been using it all year, but I'm gonna start using it. But let's see, take 2 minutes. See if you can answer this piecewise question. Give it a shot. While you guys are doing that, I want to go. All right, guys, focus. Answer this question.
I think he has a picture with you outside.
Yeah.
Yeah.
Why?
I don't know.
Group?
Yeah.
You have a question?
I don't know where my pencil is. Okay.
Is that an April Fool's?
April Fool's.
You got fooled.
You just looked at me and was like, what?
You just got
All right, guys, what?
No, what's that under the question?
Oh, wow, you guys are so cool.
You got fooled. You got fooled.
I wonder who it was.
Yes.
Probably you.
Why would it be me?
You're the closest one.
Just one.
Not Sarah.
Yeah, right. And if it's wrong, I can transfer.
All right, let's see, guys. What'd you guys get? I just heard you. You said 1. What'd you guys get? 1. What'd you guys get?
1.
It's not 1, guys. All right, guys. This is a piecewise function. It says, what is the limit as x approaches 2? So I'm going to go limit as x approaches 2 from the left of this function. If I approach 2 from the left, I am looking at this one. See, because that one's the one that has values to the left of 2. 2 squared is 4. 4 plus 1 is 5. And I'm going to go limit. And now I've got to check what happens if I approach 2 from the right. So now I'm going to look at this one because that one has x values to the right of 2. So if I approach this function from the right-hand side of 2, I'm also going to get 5. So the limit as x approaches 2 of this function is just 5. You could have also done it You could have also done it by graphing, because some of you guys are visual. You could have done a grid. And relax, this grid is not hard. It's a parabola with the vertex moved up. So this graph between -2 and 2. So here's 0, here's 1. And you could have done like, oh, okay, this one has a solid, and this one's an open, and this is 5 right there, not to scale. And then I have a point at 2, 1. So then I'm going to say this is 2, and then the point right there. That's 2, 1. And then I'm just 5 between 2 and 8. So here's 8, not to scale. 2 and 8. And then you could have also seen it like this, and you could have been like, oh yeah, limit as x approaches 2 from the left is 5. Limit as x approaches 2 from the right is 5. So the limit of this function is also 5. You're not going to get hard ones. That's for calculus. In calculus, you'll get real tough ones. In pre-cal, you just get basic ones like this. They're not going to get any harder than this for now. Next year, when you're in calculus, you'll do more advanced ones. The more advanced ones in pre-cal are like the rational ones, where you got to look at end behavior. All right, that's it. Let's do some delta math, get some experience, and we're good. Did all that make sense, guys? All
Yes.
right, let's take care of business.